need to show that the series sin x plus 1 by 2 sin of 2x plus 1 by 3 sin of 3x so on is converging uniformly in this given interval. And we are going to use the Dirichlet's test over here. So first, let's recall what Dirichlet's test states. The series of the kind summation n going from 1 to infinity, the product of unx and vnx is uniformly convergent on E if the first condition is the sequence vnx is a decreasing sequence of positive terms converging uniformly on E. This is very important. It should converge uniformly. Second condition, if there exists m positive such that taking the mod on the summation r going from 1 to n on urx, that should be less than equal to m. If there exists such m for all n belonging to the natural numbers and for all x belonging to E, then for these two conditions we say that by Dirichlet's test the sequence is converging uniformly on E. There is a remark written over here. The formula for the sine series sin of theta plus alpha up to so on sin of theta plus n minus 1 alpha. So that is equal to sin of first angle plus last angle divided by 2 into sin of n alpha by 2 divided by sin of alpha by 2. Similarly for the cosine series, cos of first angle plus last angle divided by 2 into sin of n alpha by 2 divided by sin of alpha by 2. Please remember, in the formula for the cosine series, again there is the presence of sine. So let's start with the proof. To prove that this given series is uniformly convergent by the Dirichlet's test. So this given series can be written as summation n going from 1 to infinity. This is sine of nx divided by n, right? Now for the Dirichlet's test, we need the product of unx and vnx. So let's take unx to be equal to sine of nx and vnx is equal to 1 divided by n. So the first condition for the Dirichlet's test is we need to show that this vnx is a decreasing sequence of positive terms and is also converging uniformly, right? And yes, clearly, the sequence vnx, that is 1 divided by n, this is a decreasing sequence. Of positive terms and vnx equal to 1 by n. This is converging to 0 as n tends to infinity. And because this vnx, that is 1 by n, it is independent of x, so this sequence is uniformly converging to 0. So this sequence is converging uniformly on the interval AB. Since vnx equal to 1 by n is independent of x, therefore the sequence vnx converges to 0 uniformly on the closed interval AB, right? Okay, now about the second condition. Second condition is we have to take the mod on summation of urx, where r is starting from 1 to n, and we have to show that this mod is less than equal to m, right? So what is unx? We have taken this to be equal to sine of nx. So this is sine of nx. So consider mod of summation urx, where r is going from 1 to n. So that is equal to mod of summation r going from 1 to n. So urx becomes sine of rx, right? Opening the summation, putting r equal to 1 here, we get sine of x, plus then r equal to 2, we get sine of 2x, plus so on up to sine of nx. So we are getting the sine series, right? And now for the formula for the sine series, sine of first angle plus last angle divided by 2 multiplied with sine of last angle divided by 2, and in the denominator sine of x by 2 mod, as 0 is less than x less than 2 pi. Now we know that mod of sine of theta is less than equal to 1 for all theta belonging to the real numbers. Yes? So for the numerator, we write this further less than equal to 1 divided by sine of x by 2 and the mod for all x belonging to the closed interval AB. And 1 divided by sine of x by 2 is cosecant x by 2. So this is mod of cosecant x by 2 for all x belonging to the closed interval AB. So we have got that mod of summation r going from 1 to n on u r x. This is less than equal to mod of cosecant x by 2 for all x belonging to the closed interval AB. Now we can find the supremum value of this right hand side over this closed interval AB. And let me take that supremum value to be as m. So let m is equal to the supremum of mod of cosecant x by 2 over closed interval AB. Then this left hand side, that is mod of summation r going from 1 to n on urx, this mod is less than equal to m, right, for all x belonging to the closed interval AB, and this n belongs to the natural numbers. So we have also proved the second condition for the Dirichlet's test. So now we can write that, therefore, by Dirichlet's test, the given series is uniformly convergent in the interval 0 strictly less than a, less than equal to x, less than equal to b, and is strictly less than 2 pi. Right? Okay, thank you.